This is an integration review. The directions say to evaluate the integral. On number 1, we have the integral from 0 to square root of 2 over 2 of x squared divided by the square root of 1 minus x squared dx. Now, notice how I have a right triangle. Why? Because I'm going to do this by trigonometric substitution. Now, square root of 1 minus x squared dictates that the hypotenuse, which is the side opposite the 90-degree angle, is 1. The side opposite to angle theta I will label x, and the side adjacent to angle theta will be the square root of 1 minus x squared. Now I'm ready for my substitution. So the triangle dictates that x over 1 is equal to sine theta. dx is cosine theta d theta, and the square root of 1 minus x squared over 1 will be cosine theta. Now, when x is 0, theta is 0. So I'm converting my x limits to theta limits. When x is square root of 2 over 2, theta is equal to pi over 4. So the integral from 0 to square root of 2 over 2 of x squared divided by the square root of 1 minus x squared dx is equal to. Now, I'm going to replace x squared with sine squared theta. I'm going to replace the square root of 1 minus x squared with cosine theta, and I'm going to replace the dx with cosine theta d theta. So it's all substitution all the time, okay? And my limits now go from 0 to pi over 4 instead of 0 to square root of 2 over 2. Now recall that sine squared theta is 1/2 of 1 minus cosine 2 theta. We're going to need that in a minute. So notice how these cosine theta pieces cancel. And so what I get is the integral from 0 to pi over 4 of 1/2 of 1 minus cosine 2 theta d theta. And so when I integrate, I get 1/2 the quantity theta minus 1/2 sine 2 theta evaluated from 0 to pi over 4. If I replace theta with pi over 4, I get the following. 1/2 of pi over 4 minus 1/2 sine of pi over 2 minus, and then replacing theta with 0, I get 0 minus 1/2 sine of 0. But remember, sine of pi over 2 is 1. And so the correct answer here is 1/2 of pi over 4 minus 1/2. And that's how we do problem 1. Problem 2. This is the integral from 0 to pi of t cosine squared t dt. This is the integral from 0 to pi of t times 1/2 times the quantity 1 plus cosine 2t dt. Now, I'm going to break up this integral. And so on the next line, I get the integral from 0 to pi of 1/2 t dt plus the integral from 0 to pi of 1/2 t cosine 2t dt. Okay? Now, let a sub 1 equal the first integral. So in other words, let a sub 1 equal the integral from 0 to pi of 1/2 t dt. So this is 1/2 times 1/2 t squared evaluated from 0 to pi. So it looks like a1 is pi squared divided by 4. Let a2 equal the integral from 0 to pi of 1/2 t cosine 2t dt. So this is classic integration by parts. I'm going to let u equal 1/2 t. du is 1/2 dt. dv is cosine 2t dt. And v is 1/2 sine 2t. So the integral from 0 to pi of 1/2 t cosine 2t dt is uv, which is 1/4 t sine 2t evaluated from 0 to pi, minus the integral of v du, which is minus 1/4 the integral from 0 to pi of sine of 2t dt. Now, when we take a look at this first part, observe, sine of 2 pi is equal to 0, right? And sine of 0 is equal to 0. So we're just left with this second part. So this is equal to negative 1/4 the integral from 0 to pi of sine 2t dt, which is negative 1/4 times negative 1/2 cosine 2t evaluated from 0 to pi, which is 1/8 the quantity of cosine 2 pi minus cosine 0. So the answer here is 0. So what does that say? If we go to the next page, it says the integral from 0 to pi of t cosine squared t dt is equal to a1 plus a2. But remember, when we looked at a2, we got 0. And so we're just left with a sub 1. And so the correct answer here will be pi squared over 4. Number 3. Suppose we have the integral of e to the x plus e to the x dx. So this equals, using the law of exponents, the integral of e to the x times e to the x dx. This one is not as bad as it looks. So if I let f of x equal e to the x, and I take its derivative, I get f prime of x is equal to e to the x. So let me circle which one is which. This e to the x right here, I'm calling f of x. Okay. The e to the x over here, I'm calling f prime of x. I'm done. So the answer to number 3 is e raised to the e to the x plus c. That's number 3. Number 4. Suppose I had the integral of arctangent of square root of x dx. So traditionally, I like to get rid of the radical. So I'm going to let u equal the square root of x and then square both sides. So x equals u squared, dx is 2u du. So this is equal to the integral of 2u times arctangent of u du. Okay. Now, integration by parts. I'm going to let w equal arctangent of u. dw is 1 over 1 plus u squared du. And dv is 2u du, and then v is u squared. Okay. So the integral of 2u arctangent of u du is wv, which is u squared arctangent of u, minus the integral of v dw. In other words, this is minus the integral of u squared over u squared plus 1 du. So I'm going to show you guys a little trick here. I'm going to add 1 and subtract 1 in the numerator. That is legal. Okay. So on the very next line, and then one last thing, a plus b over c is a over c plus b over c. Okay. So that allows me to split up the integral. The integrand. And so when I do that, I get u squared arctangent of u minus the integral of 1 minus 1 over u squared plus 1 du. I'm done. So this is u squared arctangent of u minus the quantity u minus arctangent of u plus c. And remember, I want to distribute the negative inside, and I want to replace u with square root of x. See, remember, u is equal to the square root of x, and when I plug that back in, I get x arctangent of square root of x minus the square root of x plus arctangent of square root of x plus c. And number 5, suppose I have the integral from 0 to 1 of 1 plus the square root of x raised to the 8th power. And again, I like to get rid of radicals as much as I can. So I'm going to let u equal 1 plus square root of x. Solve for square root of x. So square root of x equals u minus 1. Square both sides, so I get x equals u minus 1 to the second. Dx is 2 times u minus 1 du. Now we need to take care of our x limits. When x is 0, u is 1. When x is 1, u is 2. Next page. So this is equal to the integral from 1 to 2. Now remember, I'm replacing 1 plus square root of x with u. So I get u to the 8th. Dx is 2 times u minus 1 du. That's this piece. So pull the 2 out in front, and I get 2 times the integral from 1 to 2 of u to the 9th minus u to the 8th du, which is 2 times the quantity 1/10 u to the 10th minus 1/9 u to the 9th, evaluated from 1 to 2. So I'm going to pop the 2 in, pop the 1 in. So I get 2 times the quantity 2 to the 10th over 10 minus 2 to the 9th over 9 minus the quantity 1/10 minus 1/9. Right there. And so I do some simplification, you might notice, and at the end I get 1 over 45 times the quantity 2 to the 12th plus 1. So the rest of this is a lot of calculation. So this is my final answer down here. And this would be a function of asking your instructor how far they want you to go. Okay. On number 6, we have the integral from 0 to 1 of 1 plus 12t over 1 plus 3t dt. Now, there's a slick way that you can do this. Notice that 12t is equal to 3t plus 9t. So I'm going to write this as the integral from 0 to 1 of 1 plus 3t plus 9t divided by 1 plus 3t dt. And then I split the fraction. And so this is the integral from 0 to 1 of 1 plus 9t divided by 1 plus 3t dt. Okay. Next page. So this is the integral from 0 to 1 of 1 dt plus the integral from 0 to 1 of 9t over 1 plus 3t dt. Now, remember, 9t is 3 times 3t. So the integral of 1 dt is t. So I'm going to get t evaluated from 0 to 1 plus the integral from 0 to 1 of 3 times 3t divided by 1 plus 3t dt. So I do a u substitution to capture that second integral. So I'm going to let u equal 3t plus 1. Du is 3 dt. When t is 0, plugging up here, I get u is 1. When t is 1, u is 4. And so this is 1 plus the integral from 1 to 4 of. Now, remember, 3t is equal to u minus 1. So this is the integral from 1 to 4 of u minus 1 divided by u du. So over here, I get 1 plus the integral from 1 to 4 of 1 minus 1 over u du. So this is 1 plus u minus natural log of u evaluated from 1 up to 4. Okay? And so when I replace u with 4, I get 4 minus natural log of 4. And when I replace u with 1, I get 1 minus natural log of 1, and I'm subtracting those quantities. And then don't forget, I'm adding 1 over here. And so when I simplify, I'm going to get 4 minus natural log of 4, because this one will cancel off this one, and the natural log of 1 is 0. Or you can write this as 4 minus 2 times the natural log of 2. So it just depends on what your instructor wants. Number 7. Suppose I have the integral of 1 over 1 plus e to the x dx. So I'm going to add and subtract e to the x in the numerator. So on the next line, I get the integral of 1 plus e to the x minus e to the x, totally legal, divided by 1 plus e to the x dx. So this is the integral of 1 minus e to the x over 1 plus e to the x dx. And I'm done, because remember that the derivative of 1 plus e to the x is e to the x. So when I integrate, I get x minus natural log of 1 plus e to the x plus c. Number 7. Number 8. Suppose I have the integral of square root of x over 1 plus x cubed dx. This is a great question, okay? And it's real important to get rid of that radical. So I'm going to let u equal square root of x, square both sides, and I get u squared equals x. 2u du is equal to dx, right? So when I make my substitution, this is the integral of u times 2u divided by 1 plus, now remember, x is equal to u squared. So it's 1 plus u squared to the third du. On the next line, I get the integral of 2u squared over 1 plus u to the 6th du, which is 2 times the integral of u squared over 1 plus u to the third quantity squared. And so I got to do another substitution. So I'm going to let w equal u cubed. dw is 3u squared du. So u squared du is 1/3 dw. So this is 2/3 the integral of 1 plus w squared dw. Almost done. So I get 2/3 arctangent of w plus c. But remember, w is u cubed. So this is 2/3 arctangent of u cubed plus c. But u is square root of x. And square root of x to the third is x to the 3/2. So this is 2/3 arctangent of x to the 3/2 plus c. Number 9. Suppose I had the integral of e to the 2x over 1 plus e to the x dx. So this is the integral of e to the x times e to the x divided by 1 plus e to the x dx. Use substitution. Let u be 1 plus e to the x. So e to the x is u minus 1. E to the x dx is du. And so this is the integral of u minus 1 over u du. So splitting off the fraction, I get the integral of 1 minus 1 over u du, which is u minus the natural log of u plus c. But remember, u is 1 plus e to the x. Coming over here, I get e to the x plus 1 minus natural log of 1 plus e to the x plus c. But remember, 1 plus a constant is still constant. So this can be written as e to the x minus natural log of e to the x plus 1 plus say c sub 1. And then on number 10, last problem for this video. Suppose we have the integral of 4 to the x plus 10 to the x over 2 to the x. So this is the integral of 4 to the x over 2 to the x plus 10 to the x over 2 to the x. And then on the next page, this is the integral of 2 to the x plus 5 to the x dx. So it turns out we could write it this way. This is the integral of e to the natural log of 2 to the x plus e to the natural log of 5 to the x dx, which is e to the x times natural log of 2 plus e to the x times natural log of 5. We're integrating that with respect to x. That's right here. And then final. So this is 1 over natural log of 2 times e to the x times natural log of 2 plus 1 over natural log of 5, e to the x times natural log of 5 plus c. But remember, e to the x times natural log of 2 is 2 to the x. E to the x times natural log of 5 is 5 to the x. So we can write this as 1 over natural log of 2 times 2 to the x plus 1 over natural log of 5 times 5 to the x plus c. And that's going to conclude this video for an integration review, and we looked at 10 different examples. So, okay, thank you.